Another advantage of dimensions is that we can use them to derive the formula of a physical quantity. Let's see how. This method works successfully if we correctly guess various factors on which the physical quantity depends. For example, if you know work depends on force and distance. Using this method, you can easily determine the equation of work in terms of force and distance. But if you don't know what factors a quantity depends on, you cannot apply this method. Let's derive a relation for the time period of a simple pendulum, shown on this side. The possible factors on which the time period depends are A. The length of pendulum L, B. The mass of the bob M, C. The angle theta which thread makes with the vertical axis, and D. The acceleration due to gravity g. Based on the possible factors, the time period t of a simple pendulum is proportional to m raised to the power a times L raised to power b times theta raised to power c times g raised to power d. When the proportionality sign is removed, a constant comes into place. So, t is equal to constant times m raised to power a times L raised to power b times theta raised to power c times g raised to power d. We have to find the values of a, b, c and d to derive the correct equation of the time period. Now, we can write this equation in the form of dimensions. T is equal to constant multiplied by m to power a multiplied L to power b, LL raised to power minus 1 to power c and LT raised to power 2 to power d. Theta is a dimensionless quantity. So by convention, we write it as LL raised to power minus 1, which shows theta has no dimensions. Now, we compare the powers on both sides. T raised to the power 1 is equal to T raised to the power minus 2d. M raised to the power 0 is equal to M raised to the power a. L raised to the power 0 is equal to L raised to the power b plus d plus c minus c. Starting from the first equation, minus 2d is equal to 1. So the value of d is minus 1 over 2. Now, from the second equation, a is equal to 0. From the third equation, b plus d is equal to 0. So, b is equal to minus d or 1 by 2 as the value of d is minus 1 upon 2. Similarly, the value of c is 0. Substituting all these values back to first equation of time period, we get t equal to constant multiplied by m raised to the power 0 multiplied by L raised to the power 1 over 2 multiplied by 1 multiplied by g raised to power minus 1 by 2. In short, the time period of a simple pendulum is constant times square root of L over g. Now, the constant in this equation cannot be determined by dimensional analysis. However, we can find it using experiments. And for your information, the constant is actually 2 pi.